Attention, oh, everybody. You record. We're having a class, so pay attention. So we are talking about okay. So we are talking about quadratics, and from junior high school, we've already spoken about linear graphs, right? We are writing the form y is equal to mx plus c, right? Plus c, and I can see written as y is equal to ax plus b. But this time around, we want to talk about something a little bit advanced, and we call it quadratic functions. Or let me better put quadratics, it could be talking about the functions and then the equations. So quadratics are all around us. You see things like a projectile throwing something from the ground up into the sky and coming down. All those things are all graphical forms of quadratics. And when we say a quadratic equation, you're looking at an equation that is written in the form f of x is equal to ax squared plus bx plus c. Or so that's a function notation. So ax squared plus bx plus c equals 0. We call this a quadratic equation. But there's one obvious thing that should be noted about this. That would mean that a should not be equal to 0. I guess you know why. Why shouldn't a be equal to 0? Who thinks so? Esther. Yes, because if a is 0, we'll naturally leave it as this form. So it now move to become a linear function. I hope you get that. So for quadratic equations, the most important thing about it is that you shouldn't have a to be equal to 0. So this is one form of representing it. We call this the general form, or you can sometimes see it as a standard form. I'm just trying to do a quick summary because the other forms that we can write this same expression called the vectors form. And that vectors form give us a lot more information about our graph and how our graph is behaving. You can see it written as a into bracket s minus h all squared plus k. So this same thing. So this can be written as this. So there's that allowance for variety. And back to the name quad. Quad actually means what? It's a prefix. It means four. So the name quad is allowed because in the history of quadratics, they were used to find the areas of spaces. So we have to find the area of a space. That's why if we should have a square like this, I think this marker is dead. We have a square like this with an area of 36, and I'm trying to look for the sides. I'll tell you x squared is equal to 36. And then what will be the values of, so this is an example of quadratic equation, x squared is equal to 36. In this case, you're having the a to be 1, there's no b term, there's no c term. So x squared is equal to 36. What values of x can give me 36? Or what values of x can satisfy this equation? 6, right? So we can have x to be equal to 6. Or there can also be another value, negative 6. So the quadratic equation here has two real values. Or we can also have something like this. X squared is equal to 0. What will the values here be for x? X can be equal to be 0. So in that case, we have just one value for x. So x is equal to, oh, I think this is also not working so well. Any other marker here? All right, so x is equal to 0. In this case, we have just one value for x, right? Or what if we have something like this? X squared is equal to minus 7. Can we have answers? We can't have any answers, right? So in this case, we say x has no real roots. There are other forms to explain it where we talk about complex numbers and all of that. But with regards to real numbers, we will say that x has no real roots. So basically, when it comes to quadratics, we can say that a quadratic would have either no roots, has one root, or can have two different roots. I hope you get that. All right, so there are basically three ways of solving quadratic equations. Either we use a graph, a graphical method. So ways of solving quadratics. So we have the graphical method. Then we also have factorization. And the last one is completion of squares. All right, so we can use any of these three methods to solve a quadratic equation. We can use the graphical method, we can use factorization, or we can use completion of squares.